for having me, inviting me to give this talk. And thank you for all the work that's been gone on to organize all of this and get the real live interpretation as well. Today, I'm going to be talking about my new book, which is coming out very, very soon, called Silicon Empires, The Fight for the Future of AI. So I've got some slides, which I'm going to put up here. Now, this talk is going to be based upon what I talk about in my book, but it's also going to draw upon some of the updates which have gone on since I published, since I finished writing the book as well. Now, what I'm going to look at in particular today is look at the logics of expansion which are driving the various silicon empires. And here I include both corporate empires, but also geopolitical state-driven empires as well. I'm not going to talk as much about the impacts of the expansion because this sort of stuff has been talked about quite a bit elsewhere. Really good books like Karen Howe's Empire of AI and James Muldoon's Feeding the Machine on data laborers around the world. All of these things are quite useful on the impacts of these empires. I'm really curious about what's compelling them to go out and expand in the particular ways that they are. Now, I'm going to begin with a sort of introductory section here, setting out what the AI stack looks like today. Because I think there can be a lot of confusion about the different elements of the AI world. And I want to sort of be able to separate out these things because there's different sort of ideas and logics applying to each element of the stack. At the bottom of the AI stack, we have hardware. This is things like GPUs from NVIDIA, most well known, but there's also other sorts of accelerator chips involved here. So Google, for instance, has TPUs. Other companies are developing other variants on this, all with the idea of being able to train and run AI models as quickly as possible. We might also include things like high bandwidth memory here, which is becoming a really crucial bottleneck, particularly as we move into a world of AI agents and a focus more on inference than on training within AI. Now, within this hardware layer is basically dominated at the moment by one company, which has become the most valuable company in the world. And this is NVIDIA. Now, I'm old enough to remember when NVIDIA was a video game company first and foremost. They would make terrific graphics cards and you could, run the latest video games on them. Today, they're an AI company. They control around 90% of the market. And according to one metric, they have more than 90% of the research papers in 2024 were using NVIDIA chips in order to do their research. So a real dominance by one company at this particular layer. Slightly above the hardware layer, we have the infrastructure layer. So this is things like hundreds of thousands of accelerator chips all being put together and coordinated. It's the networking components which allow these things to speak to each other. It's the energy supply which allows it all to run. It's the actual buildings which are housing all of this stuff, the land, the real estate, which it's all built on. All of this might be considered at the infrastructure layer. And if we look at the infrastructure layer, there's slightly more competition. We've got competition which is between three companies rather than one company. So here we've got Amazon, Microsoft, and Google dominating about 2/3 of the global market for cloud computing. NVIDIA dominates in the hardware layer, one company, but here it is three companies. Slightly above that, we have the model layer of the AI stack. Now, there's a variety of different ways in which you can build an AI model, but for all intents and purposes, today we're talking about transformer-based neural networks, a particular type of architecture which is used in order to run things like ChatGPT and to run all of the AI that is becoming so dominant today. Now, these things can very easily be mystified. The sort of black box idea that they're incredibly complex, really, really difficult to understand. But when you break it down, they're really just two computer files. There's a run code file, and then there's a parameter file, which lists the different weights of the neural network. And this can be billions, hundreds of billions of weights, even trillions or more weights listed in this parameter file. And that parameter file is effectively taking all the internet that all the data that these companies can find, including the internet, compressing it down into this relatively small parameter file. As the sci-fi author Ted Chiang memorably puts it, he calls it a blurry JPEG of the web. Now, when we look at the economics of the model layer, there's slightly more competition here. In fact, there's sort of a surprising amount of competition at the model layer. One of the stories that's commonly told about the models, which is true, is that they cost a lot of money to train. They can easily cost many, many millions of dollars, if not $1 billion or more, in order to train these things. And you would expect, with these things being so expensive, that we wouldn't have all that many models. That's not what we find, though. In fact, in 2023, for instance, there were over 180 different models released around the world in the wake of ChatGPT being launched and the success of that app. Now, part of the reason why there's so much competition here is because after ChatGPT, loads of companies wanted to get funding from venture capitalists and other investors. And in order to say that you were an AI company and that you deserve that sort of money for AI stuff, a lot of companies thought, well, we need to make our own model. So you end up with lots of models that basically just get tossed away after a few months. But there is a lot of competition at this model layer. Finally, at the top part of the AI stack, we have the apps. And this is what most of us are going to be familiar with, the things that we interact with, perhaps on a daily basis. ChatGPT, for instance, is an app. It's built upon a particular model, GPT-5, which is running on a particular infrastructure, typically Microsoft Azure, and which is running on particular hardware, typically NVIDIA chips. But that app is the thing which is always facing the user, the thing which we sort of access. And here there's lots of competition in terms of the economic market. Basically, nobody's figured out what exactly the right app is for the AI market. And so we see a lot of experiments going on here. Some of these apps will simply provide a sort of nuanced interface to another model like GPT-5. Some of these apps will instead have complex routing systems that will take your query and determine which model is best suited to that particular query. And then some companies are building their own models and own apps based around the needs of their users. One example here, for instance, is Adobe Firefly, which is a suite of models, which have been trained on images that are not copyrighted. So Adobe wants its users to be able to use its model without fear of any sort of legal repercussions of using copyrighted information. So this is sort of the different layers of the AI stack. And I think it's really important to keep all this stuff in mind as we talk about the rest of the things I'm going to talk about, but also in discussions about, how do we develop an AI industry? How do we get AI sovereignty? These sort of big questions really hinge as well on distinguishing between different layers of the stack. Now, with all of that in mind, in this second section, I want to talk about some of the different strategies that the big AI companies are using in order to capture as much of the AI value as possible. And it's not as easy as you might think. Now, to sort of situate this, we can think about 3 different ways we might conceive of AI today. On the one hand, we have critiques of contemporary AI, which, for instance, we'll call it a stochastic parrot. The idea being that these LLMs, these AI models, are basically repeating what is in their data sets with a little bit of randomness added in. So in this case, AI can't do anything novel. It can't do any sort of innovation. It can't do creativity or true thought or true intelligence or anything like that. On the other hand, the polar opposite position, if you talk to a lot of people within AI labs, they really believe that they are building a new form of intelligence, something that is different from human intelligence and different from, say, the intelligence of other animals, but it is a type of intelligence. And this leads to speculations about artificial general intelligence and things like that as well. Now, between these two different positions, I want to take up here a third position, which has been labeled as a normal technology, AI as a normal technology. And within the work around this, there's a distinction made between AI capabilities, what AI can actually do, and AI deployment. So how AI is actually being put out into the world. And a key part here, a key point that's being made is that capabilities are developing very rapidly. And so if you're in an AI lab and you see these capabilities developing very, very quickly, you start to believe in these AGI forecasts about an imminent AGI coming. But these things still have to be applied to society. All the capabilities in the world that you might have, they still need to go out into society, into the economy, and be transformed in order to make the most use of them, to make them actually productive for the economy. And the simple point is that that takes time. That doesn't happen overnight, even as these capabilities are increasing. Now, this idea of AI as a normal technology also builds upon a longer body of research within economics around what's known as general purpose technologies, which very nicely is an acronym as GPT, goes well with ChatGPT. Now, general purpose technologies have three key characteristics. The first one is that they are broadly applicable across an economy. So they don't just work in one particular industry or one particular market, but instead they apply to many different markets, many different industries. Another key element of GPTs is that they require complementary innovations in different areas. And this means that this sort of general technology, as fantastic as it may be, when it gets applied to specific areas, new innovations have to be added onto it to make the full use of it. Lastly, GPTs also have capacity for significant internal development. So the invention of this GPT doesn't mean the end of the story. Instead, that GPT is constantly being improved. There's lots of additions which can be made to it, improvements and efficiencies and optimizations which can be made to it. Now, really central for the story that I want to tell here is that distinction between the general technology and the specific applications made of it. This diagram here on the screen, it shows that it comes from one of the first economic papers to talk about GPTs. And it shows the idea that semiconductors might be something like a general technology, but when they're applied to different applications, they require all these sorts of adaptations to be made to it. So each one of those sort of applications is a different variant of that general technology. And the combination of all of these things, the really important part about GPTs is that they end up creating a sort of virtuous cycle which leads to lots of productivity growth within an economy, lots of economic growth, and sort of dramatic social and potentially political changes as well. So all of this is embedded within this idea of AI as a general purpose technology. Now, if you are a company that's just invented a general purpose technology, somebody like OpenAI, for instance, you face a number of challenges in trying to capture the value. And this builds upon the historical research which has gone on about previous GPTs. So the first challenge of two key challenges, the first challenge is diffusion, getting that technology to actually be adopted out into the rest of the economy. And the challenge here for a GPT producer like OpenAI is that they don't typically have capabilities for the sort of downstream applications. OpenAI is first and foremost an AI lab. They are a research company. They do not have, for instance, specialized knowledge about education, about finance, about healthcare, all those sorts of downstream applications. OpenAI relies upon other companies in order to do that sort of thing. And diffusion is difficult and it takes a long time. Historically speaking, it often takes years and decades for a general purpose technology for its full sort of potential to be rolled out. And with generative AI, we can already see the sort of difficulties in adopting that technology in different sectors. You have to figure out things like use cases. You have to figure out customized interfaces that might be useful. You have to have knowledge of domain-specific regulations. You have to think about new modalities, so not just text, but perhaps medical imaging or chemical imaging and things like that. You might have to build new specialized tools, which can be sort of welded on to these AI models. And then you also have to think about domain-specific benchmarks as well to be able to tell, are these AI models working or not? Are they actually useful? Which one is better? Which one is worse? All of this takes a lot of time, thought, resources, energy. It's not a simple process. So this is the first real challenge for these GPT companies. How do you take this general technology and get it actually diffused out into the economy? Now, one really interesting answer which has emerged since I finished writing the book, so this didn't make it into the book, unfortunately, but OpenAI has created a new role that they call forward deployed engineers. And what these FDEs do is that they go out to particular customers of OpenAI and they work very closely with them on site. So they work on these sort of downstream applications. And they try and understand how to adapt AI and adopt AI into that particular niche. So the image here, for instance, in the background, is of one of OpenAI's forward deployed engineers working with John Deere in the agricultural sector. And these aren't just sort of the companies that OpenAI works with aren't just chosen randomly. Instead, as this quote here says, FDEs also align with OpenAI's research objectives and work with customers who can most likely build solutions that help advance the research direction at OpenAI. So to give one example here, this FDE that was working at John Deere, one of the things that he found out was that John Deere needed much better voice technology for the AI models. So they made that improvement for John Deere's AI model, and then they rolled that improvement back into the general model of GPT-4 and GPT-5. So this is a really good example of those complementary innovations from a general purpose technology being used to be rolled back into and improve that general technology. Now, if you are a GPT producer like OpenAI, diffusion is just one part of the problem. You can imagine a scenario where these AI models have been diffused across the economy, but you're not getting any of the value. Perhaps all the value is going to companies like John Deere or to healthcare companies or to education companies. So the second challenge is actually capturing that value. And historically, the record isn't good for GPT producers. It's very difficult for them to capture any sort of downstream value. Part of this is, again, because GPTs are a general technology, and trying to create a sort of narrow technology which works in agriculture or healthcare or education is really costly and challenging, and it makes that general technology producer dependent on all of these smaller, more niche markets. GPT producers are also intermediaries in value chains. So they are not they're not a sort of key supplier. They're not a sort of final consumer. They are producing an intermediary within a value chain, which means that they have powerful interests on both sides of them, whether that be infrastructure companies or hardware companies or these sort of niche market companies. So it becomes very difficult typically for GPT companies to capture much of the value. It goes elsewhere. Now, these two challenges of diffusion and of value capture, I think are how the AI companies are trying to approach their strategies right now. Whether consciously or unconsciously, each of them in different ways is trying to solve these two challenges and capture as much of the AI value as they possibly can. Now, I've got a big diagram here of the 4 different strategies that I want to talk about. I'm not going to go through it on this slide. I'm going to go through it a bit more piecemeal in the slides to come. But there are 4 different strategies I want to talk about: infrastructure, frontier, conglomerate, and open. The first of these strategies is what I call the infrastructure strategy. And the most notable companies here are Amazon, Microsoft, and Alibaba. There's other examples as well, but these are key examples. And for them, the key goal of their strategy is to maximize the usage of any AI model. Doesn't matter what the AI model is, as long as people are using AI, they benefit from it. And their answer to the question of how to capture value is to take a slice of every single AI use that is possible. I'll give an example of this. When DeepSeek released their R1 model, which threw stock markets into disarray, and companies like OpenAI were really worried that maybe we don't need to be spending billions of dollars to train these AI models. Microsoft's CEO came out and said, actually, DeepSeek is great. The reason why is because they're not in the business of trying to train huge, massive models. They're in the business of trying to get as much use out of AI as possible. So the cheaper AI is, the better it is for Microsoft's business. Now, as a strategy, there's 2 key things that infrastructure companies are trying to do. One is to get as many AI models on their platforms as possible, so to increase the supply of models available. So this means things like cloud credits to get AI startups to use your particular your infrastructure. It also means things like partnerships with companies like Hugging Face, which is a massive repository for AI models. But then you also want to increase the demand for these models. And what these companies have been doing is trying to minimize any sort of adoption hurdles for their customers. So for instance, they offer loads of free training programs for people. And these training programs, they could probably charge for it if they wanted, but in most cases, they're absolutely free because they want businesses to know how to use AI, to demand AI, and then to pay Microsoft and Amazon, this money for using the infrastructure. Now, a second strategy, which is quite different, is the frontier strategy. And this is most closely associated with companies like OpenAI, Anthropic, and I would put DeepSeek in this category as well. And here their goal is to maximize the usage of a very specific AI model. So if the infrastructure companies don't care which AI model they use, these companies care a lot about which model is being used. And their core sort of strategy is to become the hub of an ecosystem where they can then capture value and control the larger AI market. I'll give a really good example of this, which has just happened in the past couple of weeks. OpenAI is including apps into its ChatGPT interface and trying to basically make a sort of app store for its AI platform. So much in the same way that Apple became a hub of a large ecosystem and is able to capture immense amounts of value there, OpenAI is trying to do a similar sort of thing, to become a hub of this ecosystem where they can then centralize value. Key to this strategy is that you have a model which is better than anybody else's. So this is really driving this sort of race for AI capabilities, because each of these companies that's operating in this strategy is trying to beat the others. And the risk is that if your model isn't better than anybody else's, then the competition becomes over price rather than capabilities. And if it becomes over price, you end up with a low margin business rather than something which is actually going to add a lot of value to your company. So lots of different efforts going on here through this frontier strategy to try and ensure that these companies become hubs of ecosystems. The third strategy is the conglomerate strategy. There's really only two companies that I think are doing this, Google and Huawei. And this is because the conglomerate strategy is incredibly difficult to do. It involves a load of resources and capabilities that are very unique. Most companies don't have the capacity to do this strategy. And the idea here is that rather than trying to become a hub of an ecosystem, rather than trying to be the infrastructure of all these different AI applications, instead, these companies are actually going out to the downstream applications and building materials, building models and services directly for them. So, for instance, Google has been building loads of healthcare models. They've been building education models, mathematics models, chemistry models, biology models, all these different sectors. Google is building specific niche models, AI approaches for them. Huawei is doing a similar sort of thing, but more oriented towards the economy of China. So for instance, they have a model called Pangu Mine, which is built for the mining industry within China. They're also making investments and acquisitions into these domains as well. So trying to buy up companies and get some insight into what these particular industries want. All of this is an effort to really expand out into these downstream applications in a quite unique way. Then the last strategy I want to talk about is the open strategy. And this has been most closely associated with Meta, although they may be turning away from that at the moment. But Chinese companies have really taken it up since the launch of DeepSeek, particularly from January of this year onwards. And Alibaba has become a really dominant player within this strategy too. And the idea here is that you're not going to try and capture monetary value directly, but instead you're trying to capture distributed, decentralized innovation. So you release a model, you allow a community of volunteers to play with it, to update it, to improve it, to mess around with it. And then any sort of innovations which are created there, for instance, maybe the community makes inference faster and cheaper, maybe they improve the context window size, all of these things that might be improvements, all of that can then be rolled back into Meta's main model for free. For Meta, this reduced the cost of development and it reduced the costs of running their own internal systems. And I think for Chinese companies, one of the interesting elements of an open strategy is that it also reduces the impact of US trade restrictions. So DeepSeek has said very explicitly they want more compute and that the export control laws banning them from getting NVIDIA chips are a real hindrance in their efforts. But if you have an open model, effectively what you're doing is using the compute that you can get access to, sending that model out into the world, and then relying upon that decentralized compute around the rest of the world to continue to improve that model. So this is, I think, a really interesting way to sort of circumnavigate those trade restrictions. Now, one of the key things that these open strategy companies are doing is really trying to facilitate the take-up by a wide community of these models. So providing loads of documentation, for instance, developer tools, all sorts of assistance so that these sort of individual hobbyists and these volunteer communities are able to play with these things and improve these models. In Llama's case, they're also really trying to foster a brand and associate Meta with open source more broadly. For instance, if you make modifications to the Llama models, you have to include the Llama brand name within any sort of derivative as well. So everybody knows it is a Llama model. So those are 4 different strategies that I think the big AI companies are doing to try and capture value and try to foster diffusion of AI throughout the economy. There's a sort of schematic representation of it here on my slides. What I think is particularly interesting about these different strategies is they lead to different actions, but they also lead to different sort of tensions and failure modes, sort of points where further developments in the AI world might be a real benefit for these strategies or might be really negative for these strategies. So I give some examples here. On the one hand, models might become commoditized in the future. This might happen if we sort of hit a wall in terms of developing AI and everybody starts to converge on the same capabilities, and the competition becomes not over who has the best model, but who has the cheapest model. In that case, this is great for infrastructure companies because it means more people, more businesses are using AI as it gets cheaper. It's great for conglomerate companies because it means, again, more people can adopt their models. And it's good for the open strategy because it means they can compete with the frontier models. They can be as good in terms of quality. For a frontier company, though, this is basically the end of their strategy. If models become commoditized, they will see the end of any sort of real revenue, the end of any sort of hopes for profit, and the end of their business. We might also see models continue to increase capabilities. And this could be good for infrastructure companies because then it would mean more people are finding AI useful as it's able to do more and more people are then relying upon these cloud companies. For frontier companies, it's also really good because it means that you're able to compete not on price, but instead on quality. For conglomerate companies, it's probably a bad thing, though, if models continue to increase capabilities, because what it might mean is that you develop a specific model for, let's say, finance, but then GPT-6 comes along and basically makes that obsolete. So if capabilities continue to improve, we might not need these conglomerate approaches. And then for an open company, if models continue to increase capabilities, it becomes more and more expensive, more and more difficult to keep up with those frontier companies. So I think it's a real bad thing for that particular strategy. And then if inference moves to the edge, so the edge is things like the devices we have in our hands, phones, laptops, desktops, things like that. If running an AI model starts to move towards the edge, this is bad for infrastructure companies because nobody needs them anymore. But it might be really good for open source companies because then more and more people can take up these open models and have them on their phones and things like that. Okay, so that is 4 different corporate strategies. But of course, AI is not just about capitalism today, it's also about geopolitics. And here there's a real effort to control AI value, particularly amongst China and the US. Now, general purpose technologies have historically been central to major transformations in the balance of international power. So when a new GPT comes along, it can often really upset the dynamics of the international order. It's no surprise then that AI is seen as a core geopolitical focus by today's great powers. There's a fantastic book by Jeffrey Ding called Technology and the Rise of Great Powers, which looks at all of this. And he argues that there's 2 different ways in which GPTs might be thought to impact the balance of international power. Now, the traditional way in which this has been thought about is that a leading sector says that innovators in the GPT, they grab these monopoly profits by being so innovative, and then they use those monopoly profits to boost the rest of the domestic economy, and that boost to the domestic economy then gives you political power, military power, and ultimately international power as well. That's the traditional story. And Ding argues for a different story, which he calls diffusion theory. And he says that, in fact, what's really important is not who is leading in innovation, but actually who is best placed to adopt these GPTs. And that widespread adoption leads to productivity increases not in one sector, but across many different sectors of the economy, which then leads to that boost in the domestic economy, which leads to military power, which leads to international power. So his argument is that diffusion theory better explains the historical situation. But I think this distinction between a sort of innovation approach and a diffusion approach also really gets to the heart of a difference between the US's approach to AI and China's approach to AI. So America, very simply speaking, has an innovation approach to AI. They are trying to advance the AI frontier as rapidly as possible, fueled by immense amounts of private investment. They have a deregulatory agenda domestically to try and support this, to try and allow this stuff to go as fast as possible. So deregulating, for instance, energy. There was an attempt to ban any state laws being made for 10 years around AI. That failed ultimately, but it shows the real deregulatory impulse of this race towards AI in America. There's also, particularly under Trump, there's been a real minimization of any sort of concerns about AI safety. The sort of 2023 worries about existential risks of AI completely have disappeared under Trump. And then the US has a number of different market-led industrial policies that it's using to support AI industries. So for instance, investments into Intel, support through the CHIPS Act and things like that. All of this is in an effort to basically race towards building artificial general intelligence. That is America's core strategy here. China, by contrast, is a very different focus. And from people who speak Chinese, all I can gather is that mentions of artificial general intelligence are very rare in government documents. It's just not something that is the focus of China's core strategy. Instead, they're trying to diffuse AI tools throughout the economy. So there's lots of government support for pilot projects. There's lots of support for local experiments with AI applications. And there's lots of support for small businesses to take up AI, play around with it, explore it, see what it might be useful for. Different policy instruments are being used, lots of different government subsidies, different policies, tax breaks, procurement, etc. All sorts of things being put in place to support the application of AI within China. Now, I think one way to encompass this distinction between the two different strategies can be seen in how each country is approaching building compute. So in, I think, January of 2025, Trump stood alongside OpenAI to announce this Stargate project that was being built. And the idea is building massive compute clusters, the biggest data centers that the world has ever seen, but designing them for one single company to use, OpenAI. And ultimately, using these data centers to train one really big model. That's effectively what is going on here and what they want to do. By contrast, in China, you have a similar sort of policy in ways, which is called the East Data West Compute project. And the idea here is of using those sort of developed regions in the east of China, using the data from there, shipping it out to new data centers in the west of China, which are less developed, and then having the compute run in that west part. Now, instead of building massive clusters, they're trying to build decentralized compute clusters, multiple different compute clusters around different parts of China. Instead of providing compute for one company, they're trying to provide compute for many different organizations, companies and local governments and provincial governments. And they're not just trying to train one giant model, they're trying to train multiple models and run different models. All of this is, again, it's providing compute for the whole economy rather than just one company. On top of all of that, it's not just about building AGI. The East Data West Compute project is also a regional development project as well. So it's a way to try and get some investment into these Western regions, which are not as well developed. So I think that is, a very striking embodiment of the differences in strategies here. Now, there's also different strategies when it comes to expansion abroad. And this is where that sort of empire element starts to come into play. The American form of expansion for AI so far has been leveraging that control of frontier technologies in return for expansion and dominance of the US AI stack. So under Trump, I think it was in June or July of this year, they released what was called the AI Action Plan, which called for quote unquote full stack AI export packages. So not just exporting, American apps or American models or American chips, but the entire American stack of AI technology should be put in place in other countries. That's what this plan calls for. They've been making deals with countries and again, using their leverage over frontier technologies like NVIDIA and OpenAI and the cloud computing giants, using that leverage to try and turn countries away from China. The deal that was made with the UAE, for instance, is a really good example. The UAE had quite strong connections with China, but the US forced the UAE to get rid of those connections in return for getting access to lots of NVIDIA chips. So this is the American strategy, force people to take your side by leveraging that access to the frontier technologies. And then again, fighting any sort of international regulation of AI. So even the most sort of minimal safety elements that might be put in place, the US under Trump has been really vocal against any sort of international regulation. China is quite different. And it's really started to take shape this year, I think. Their particular strategy for exporting Chinese AI to the rest of the world. As Trump has sort of stepped back from any international efforts and any multilateral efforts at regulating AI, China has started to really step in and take leadership of these global governance efforts. It's made proposals for different global governance bodies and things like that. It's been pushing for international standards around AI safety and things like that. It's been a vocal supporter, but it's also been a really big supplier of open source AI. And open source AI is a very nice way to, again, get companies around the rest of the world to take up your AI model. You don't have to pay money in order to get access to it. You simply download it from Hugging Face and away you go. China has also been offering support to Global South countries to build up their technological capabilities. There's not a lot of this in practice yet, but they've been vocal about wanting to do it. We'll have to see what that actually means in practice. But this is a very different approach, again, from that American approach to expansion, which is sort of pushing for decoupling from China and sort of coercing countries into taking up the US AI stack. Now, there are tensions within each of these two countries as well, though. And I think particularly under Trump, there is a lot of different policies and actions which are contradictory at points. And I think this reflects not just Trump as an individual, but I think it more broadly reflects that the US ruling coalition is in fact divided. Under, let's say, Obama, what the tech elite wanted in Silicon Valley was what the political elite in Washington wanted as well. There was a real harmony of interests between the tech elite and the political elite. That is no longer the case in America. You have big tech companies, which are neoliberal at heart, pushing for global markets. They want to get access to all of these different markets around the world. They don't want export controls. They don't want trade restrictions. They don't want this trade war with China going on. On the other hand, you also have in Silicon Valley an emerging defense tech scene, which is pushing for economic security as the primary goal of US technology. So pushing for, profits being secondary to thinking about how do we maintain our supply chains? How do we build the best weapons? How do we ensure that our rival countries don't get access to this sort of stuff? And completely reorganizing neoliberal globalization as we knew it. You also have mixed in with all of that Silicon Valley sort of libertarians. And I think Elon Musk's brief foray into the US government is a good example of this, which pushed for the demolition of the state apparatus. So taking down a load of different things which are really crucial, like support for research and support for science in America, and support for immigration, which allows foreign researchers to come to America. All of that has been really demolished under the Trump regime so far. On top of all of that, you have Trump, who as a person has been making loads of aggressive statements towards former US allies. And it makes these US allies very wary of being dependent on US technology. Europe is probably the biggest example of this. There's been a real massive push for digital sovereignty in the wake of Trump's statements around, how he wants to treat allies. So there's a lot of different elements going on here within the ruling coalitions of the US. But there's also tensions within China as well. And this is coming to the end of my talk here. You don't have a lot of concern in China about AGI, but there is a small and growing concern about what artificial general intelligence might mean in terms of safety and in terms of geopolitics. So you have people starting to move away from that real focus on diffusion of AI towards thinking about how do we lead in innovation. There's also been a move since about 2021 where the government has started to prioritize its relationship with hard tech companies, like Huawei most notably, and sort of displaced its former priorities, which were companies like Alibaba and Tencent. So those platform companies have sort of seen their position within the government and within the ruling coalition sort of downsized a little bit and been replaced by companies like Huawei and SMIC and SME, these various semiconductor companies. There's also, however, tensions within some of the AI companies in China who want to get access to the very best chips from NVIDIA. But the government is now saying, no, we need self-reliance at all costs. Do not buy any more NVIDIA chips. We will block it. We will ban it. So all of these efforts to, push Chinese companies away from that dependency on NVIDIA, but the AI labs would still like to use the best chips available. And then lastly, I think one of the most interesting tensions in China's AI policy right now is over open source. Open source is really great in terms of diffusion of that technology and expansion of that technology around the world, but it does raise a load of censorship concerns for a government which is, very concerned about these sort of things. Open source AI can be modified in very different ways to say loads of different things. So there is a tension here, I think, with that sort of desire for social control, but also that desire for fostering open source AI and its benefits in China. So all of this is to say that America has an innovation strategy, China has a diffusion strategy, but these aren't set in stone by any means. There is a sort of ongoing tussle at the upper levels of these governments to try and transform what might be possible with these strategies. Now, I see three different competing outcomes, and this is my final slide here. Possible outcomes for the world. On the one hand, we might see fully decoupled hemispherical stacks. So there would be a group of countries aligned with the US and have US technology, a group of companies aligned with China with Chinese technology, and perhaps the EU might form a sort of third position within all of that. I don't think that's going to happen. I think the technological hurdles to doing that are immense and very unlikely. Instead, we probably will see things like polyalignment and the overlapping of distinct technological stacks, where countries try and weave a pathway between the US and China and try and include these different elements of the technological stack together. I think we're also likely to see a multiplication of digital sovereignty projects. The EU is the biggest example, but there's loads of other examples around the world of different digital sovereignty projects that have been launched in an effort to maintain some sort of national autonomy in the face of this ongoing geopolitical struggle. So this is sort of how I see the landscape of AI today, and hopefully you find it to be a useful framework as well. Here are references if anybody's interested, and thank you very much.